Okay, so there was a question about residuals, and I wouldn't, these came from my 2040 notes. I wouldn't actually.
You don't need to know. You probably shouldn't.
Yeah, I don't even need to, you don't need to worry about it. I will say this, I do want you to know what a residual is, but that's about it. So your residual equals your actual value minus your predicted value. Okay. Now the lecture that I posted last week, once we start getting into the residuals, we kind of get into the weeds. You don't need to worry about that. But let me just explain to you what I mean by that. Remember, if you've got a scatter plot, okay, you've got a scatter plot that looks like this. Okay. We're going to draw our ordinary least squares regression line. Okay. So I'll pick a different color like red. This distance here between the actual value and then the line is your predicted value. That distance here is a residual. That's what it is. So the word largest should not be in there. So this is what it is. Your residual is your actual value minus your predicted value. That's all you need to know. Okay. Now the rest of that lecture was for my 2040 class. And it's interesting for my 2040 class. You don't need to know it, but yeah, I do want you to know this. The residual is your actual minus your predicted. So apparently my notes were wrong on that, and I will fix that. Okay. Thank you for pointing it out, and I'll fix my notes. Yes.
Don't need to know positive or negative residual at all.
If you were in my 2040 class, yes, but no. Okay. No, that's fine.
Are our notes like kind of mixed in with the 2040 class because some stuff we didn't talk about? So.
Like what didn't we talk about?
That's what I'm thinking.
Okay. Hold on, let me find it. You can keep talking. I'll find it.
I don't have anything to say, so here I'll stop recording. Okay, so we're recording now. I do want to say, please remind me, just so you know, so we're going to have our test next week, like I mentioned. I'm going to give you guys a formula sheet. I'm actually going to give you a formula sheet that we'll use for the rest of the semester. This will be the formula sheet that I will provide for both your written and your computer tests. So if I don't post it today, somebody send me an email, remind me, so just so you can get familiar with what you will see. So it's going to have some tables, it's going to have a bunch of formulas and that sort of thing. So just wanted to mention that. So we're going to start with chapter 11.
Have you posted this chapter yet?
Yeah, I posted it this morning, I think I did. Chapter 11, which is expected values. I also posted the homework. Pretty sure I did. Yeah, I did that during my last class, during their quiz. What'd you say? They're not? All right, so we're going to find the expected value. So basically, you can also think of this as the mean. It's another word for the mean. So it is found by multiplying each value by its probability. Okay, the formula mu equals the sum of x times p of x. Okay, I wanted to do this right after we did the probability section, but this will be kind of a good review for some of you. But the problem was I got the library, and so I wanted to use it for, and we have apparently a limited number of uses of the library classroom. So I wanted to utilize that for stuff that worked a little bit better. So let's say that, for example, what is the expected number of cars in an American household? Okay, let's say that we get the number of vehicles and we get the proportion from the Census Bureau. Okay? So I'm going to have, these are the number of vehicles per household. So I've got 0, 1, 2, 3, 4, and 5 or more. That's for people like Jill and all that collect cars. Okay. All right, and so from the Census Bureau, they tell you that this value is 0.1, 0.34, 0.39, 0.13, 0.03, and 0.01. Okay? All right, so this is the formula that I'm going to give to you guys. And basically what this does is it says take every x, multiplying each value, so you can think of each value as the x, by each probability, which is your p of x. Okay? It's actually, in fact, one of the easiest things that you may do is you may, if they don't give you a table, create a table, such as this. Okay? So all I'm going to do is I'm going to multiply these. 0 times 0.1 is 0. 1 times 0.34, 0.34. 2 times 0.39, 0.78. 3 times 0.13, 0.39. 4 times 0.03, 0.12. And I'm just going to, it says 5 or more, I'm just going to go with 5. It's good enough. 5 times 0.01, 0.05. Okay? Now, what does this mean? Add them up. I'm going to add all those numbers together, and that equals a grand total of 1.68. Does that seem pretty reasonable to you? The average American household has 1.68 cars.
Well, there's not really half cars, maybe 2 cars.
You bring up a good point. There's not a half a car. But for an average, you know, we talk about the average, how many children do you have? You've got 2.3, you don't have 0.3 of a child, but that would be the average, okay? Or the mean, okay? So let's do another example. Maybe I'll go over here. Okay, let's say an insurance company pays $250,000 if the policy holder dies. The policy holder pays $350 per year. Probability that he lives equals 0.998936. Find the expected value to the insurance company. Insurance company. Okay, so we're thinking about this from the insurance company. Now we talked a little bit about our sample space. Okay, now one of the easiest things to do when you're doing expected value is to find your x and to find your p of x. Okay, now the value to the insurance company is what? How much money is the insurance company going to get from this policyholder? $350. Okay, if the insurance policyholder dies, how much are they going to pay out? Yeah, they're going to pay out, I think there's a typo on my thing. This should say $250,000, and it's going to be negative because they're paying it out. So this is positive, that's going to be negative. My notes, let's just go with the 250,000, okay? All right, so now the probability that he lives is what? This value here, right? 0.99896. What's the probability that he dies? 1 minus that, right? 1 minus that number, which equals 0.001064. Okay, it's that value there. Okay? Now, when we're doing expected values, what are we doing? We just need to find x times p of x, right? So 350, who's got a calculator? 350 times 0.998936 is?
$349.6276.
349.6276. Okay. What's negative 250,000 times 0.001064? Negative what? 266 point. Oh, even? That's it? Okay, so what do I do with these numbers? What does this mean? Add them up. What's 349 minus 266? 83 even. 0.6276, isn't it?
Yeah.
6276. If we round that to the nearest penny, they're going to make $83.63 per policy. Okay? Now, if you think about this, 1 out of 1,000 people will die, right? So 1 out of 1,000 people, they're going to have to pay $250,000. But 999 of them, they're going to be making $350. That works out to an average per policy. They're going to be making $83.50 per policy. Does that make sense?
It's not variable, just a P of X, just derive that. About 349,000 per 100.
This it says
Yeah, what
product.
does that say?
Product.
Okay.
Okay. Does this make sense?
We do another one.
We can. I'm going to have you guys do it though. Make sure you know what you're doing. Okay. Enough room there, hopefully. All right, let's say that you ask a basketball player to shoot 3 free throws and record the number of makes. Okay? So you get the following table. I've got X and I've got probability of X. Okay, so I've got 0, 1, 2, or 3. If you shoot 3 free throws, how many can you make? 3 or 2 or 1 or 0. You can miss all 3 of them, right? Okay, so you can think of this as your sample space. You guys remember sample space? That was like 2 weeks ago, right? Can't remember 2 weeks ago. Okay, so you have the person do this a bunch of times. You find that the person makes 0 1% of the time. They make 1 10% of the time. They make 2 38% of the time. And they make all 3 51% of the time. Now, let me ask a question before we find the expected value. Is this a legitimate probability distribution? Clean up those cobwebs. Sydney, what do you think? Yes, because?
Well, they all add up to,
Say that again?
they all add up to 1.
They add up to 1. This column should add up to 1. Can you guys verify that she is correct? That is correct. Okay, so, and what's the other rule about probabilities? There's 2 rules. It can't be negative, it must be greater than or equal to 0, and less than or equal to 1. Okay, so this is a legitimate probability distribution. Now, let's ask this question. I'm going to keep it over here. What are the expected number of free throws made? How would you figure that out? It must be Morgenstern. What do you think? Multiply them. See, I know you know what you're doing. Okay, so we're going to find the product. Would you feel comfortable doing this both on computer and on the board? Okay, so I'm going to multiply 0 times 0.01, and you can tell me that is 0, and 1 times 0.10. 0.10, the human calculator from Oregon. 2 times 0.38. 0.76. 3 times 0.51. 1.53, very good. Now what do?
Yeah.
Add them up and we get, somebody's got a computer there. What's your name again? Sarah? Ashley. What is it? 2.39. So let me think about that for a minute. Does that seem like a reasonable number? If you're going to shoot three free throws, does 2.39 seem like a reasonable number? Yeah, it's not. They're either going to make 2 or you're going to make 3, but as an average, 2.39 seems reasonable. Would 7.2 seem reasonable? No. Okay, it's got to be between 0 and 3, right? Okay. All right. So this will be a good review. You guys wanted to, you guys have had enough time to forget about all your probability. We're going to bring it back. Yes.
So the middle column of that table is probability, right?
Yes.
P of X. How is there a 1% chance if you shoot it 0 times?
Okay, so you're misinterpreting that. So the question was, I don't know if people could hear that. Why is there a 1% chance that he shoots it 0 times was the question. No, that's a misunderstanding. He's shooting 3 free throws, and these are the number of makes. So out of 3 free throws, he made 0 1% of the time. Out of 3 free throws, he made 1 10% of the time. So let's say that he shoots 3 free throws. You count the number of makes. Let's repeat this 100 times. So 1 out of 100 times, he missed all 3. 10 out of 100 times, he made 1 out of 3. 38 out of 100 times, he made 2 out of 3. And 51 out of 100 times, he made all 3. Okay, this is not Shaq, right? Shaq's not making all 3. Okay, does that make sense now? Caleb? Okay, all right. So let's go back here. I really wish I had an eraser. Yeah. All right, so let's say, this is good because now we start throwing probability at you, okay? A tri-state lottery allows customers to pick a 3-digit number. If it matches exactly, the state pays $292. If the digits are out of order, the state pays $42. Oh. This was actually a harder one than I anticipated, but that's all right. We'll do them both. What are your expected winnings? And maybe I should say losings. Because this is gambling. What do you expect? You should not expect that you're going to make money. Okay? All right. So I'm going to pick on, is it Sarah? Oh, good, it was. All right, I got her name. She's in trouble now, I remember. Okay, Sarah, give me pick a 3-digit number. What do you think's going to win?
112.
112. Okay, 112. That's your number. Okay, so let's think about this for a minute. I think I showed you this technique before. So, well, actually, let's do this. We got X and we got probability of X, right? Okay. So, how much money can you win? Sarah, we'll keep with you. That was too easy of a question.
292.
You could win $292, right? Or you could also win $42. Or you could lose, right? How much could you lose?
How much is it?
50 cents, right? You could lose your ticket, right? So that's going to be a negative number because you're going to lose it, negative 0.50. Okay, does that make sense? Do you understand how I got the X?
Will you give us like the 50 cents on a test? Or should we just know that?
Yeah, well, yeah, I mean, you would need to know something like that in order to do this problem, yes. Okay? You bought the ticket, right? Yes, Ben.
So it says on here $1. How did you get 50 cents?
Oh, did they get $1? Because I mixed up the two problems. Let's make it $1 then. Okay. I started doing the one problem and I switched to the other. So we're going to do $1 bet. Oh, it costs $1. Okay, so it's now $1 bet. So negative $1. Okay? All right, so Sarah picked the number 112. Let's think about this for a minute. We've got 3 digits here, right? How many choices does she have for the first digit? No, for the first, just the first digit.
10.
She's got 10 choices for the first digit. How many choices does she have for the second digit? 10 choices. And for the third digit? 10. Tell you what, I'm going to change your number. Sorry, I want to change it to 1, 2, 3. It's going to make it a little bit easier. Okay? It's a better demonstration. Okay? All right, so the winning number is now 1, 2, 3. Okay? So so how many total, so 10 times 10 times 10 is what? 1,000. So there's one way to win out of 1,000. Does that make sense? Okay. Now let's say that rather than 1, 2, 3, they pick 1, 3, 2. How much money is she going to win? $42. Now, what are all of the possibilities besides 1, 2, 3 of using those numbers? So there's 1, 3, 2. There's 3, 2, 1. There's 3, 1, 2. There's 2, 1, 3, and 2, 3, 1. Right? Are there any others? Okay. So these are all the possibilities to win the second prize, right? So how many ways are there to win $42? 5 out of 1,000. Are there any other ways to win? Okay. So we've got 5 here, we've got 1 here. So there's 6 ways to win. How many ways are there to lose? 994 out of 1,000. They never tell you that, do they? Emily,
I think I'm confused where you're getting the 5 out of that.
okay.
Just re-explain it real quick.
All right, so she can win if they get her numbers in order, right?
Okay.
So there's only one way to win this way. But if let's say instead of 1, 2, 3, they pick 1, 3, 2.
Okay.
That's a one way to win $42. Okay, so if they pick these 3 numbers but in a different order, how many different ways are there to use the numbers 1, 2, 3?
Okay.
There's 5 ways. Okay,
Thank you.
that's how we got that. Okay, so now, Jordan, what is her expected winnings or losings?
So is this when we add up all the probabilities?
Well, if we add up all the probabilities, what should they add up to?
That should add up to 1,000.
Should add up to 1. 1,000 over 1,000, yes. Okay, which is good. Are these negative?
No,
No, that's good. Are they greater than 1?
they are 1. They're not.
Well, each one of them individually.
Oh, no.
Yeah, they're not good. So yes, it looks like we set this up properly because that was up to 1. Okay, so now how do we find the expected winnings or losings?
So you times the,
So we're going to multiply these product. I didn't give myself enough room, did I? Okay, but 292 times 1,000 is 0.292, right? 42 times 5, I don't know what that is. 0.21. And negative 1 times 994 is negative 0.994. Okay,
and then we sum all those.
I'm going to sum all those up. What do I get? I think I got negative 0.492. Okay, so what does that mean? Okay, for every dollar bet that you make, how much are you going to win or lose?
Lose 49 cents.
You're going to lose 49 cents. It's a good bet, right? Who wants to make this bet?
I'll do it.
It's for a charity, right? Yes.
I have a question. So when you're just like getting the product, you didn't divide by the 1,000, right? You just times like 42 by 5.
And divided by 1,000.
Okay. So
Okay.
on the,
Okay. All right. Should we do a different bet? Let's see if you guys can do this one. Okay. Hopefully this one's easier than that one. Okay. We're going to make this a simpler bet. Oh, no. This is really an eraser. Is there really not an eraser in here? All right. So we're going to do a different one. We've got the tri-state lottery. Has a different bet. For 50 cents, you can choose 1 3-digit number. The state pays $250 if they pick your number. That's it. What are your expected winnings / losings? Okay. Seth, it must be your turn.
Oh, boy.
What do you want to start with? What do you want to make first?
Find the X value.
Find the X values. What are the X values?
Is that 250?
You can win $250.
Negative, what's that, 50 cents?
Negative 50 cents. Okay? All right, now let's figure out our probabilities. Okay? Let's pick the same number that Sarah was supposed to pick. 1, 2, 3, right? That's our winning number. Okay? What's the probability the state picks that number? Do you know how to figure that out?
Is it out of 1,000?
Yeah, it's going to be out because we did that on the previous problem, right? You've got 10 choices for the first digit, 10 choices for the second digit, 10 choices for the third digit. So that would be 1,000 ways, and you're only going to get it one time, right?
So it's 1 out of 1,000.
1 out of 1,000, and you're going to lose
999 out of 1,000.
999 times out of 1,000. Okay. Now what?
Multiply those together.
We're getting a nice pattern here, right? You liking this problem? Sort of? Okay, we're going to find the product. 250 times 1 over 1,000 is 0.25. 0.50 times 999 over 1,000 is negative 0.4995. We're going to add those up, and we're going to get negative 0.2495. So what does this mean? You're going to lose 25 cents each time. So which is the better bet? That's a better question. Which is the better bet?
Well, you have a better chance.
You want to lose 25 cents or do you want to lose 50 cents?
Your chances are better.
Your chances are better? You've got more ways to win and more ways to lose. Well, actually, fewer ways to lose, you're right. But you're risking more money too. So do you want to lose 25 cents per bet or do you want to lose 50 cents per bet? There are more ways to win, right? But it's more expensive to lose. Personally, I would rather lose only a quarter than 50 cents.
I'm not a risk taker.
I'm not a risk taker. Okay? All right. That was nice and easy. Okay, so let's do a review. We had 2 questions. Morgan wanted to go over the
I know you were going to tell me that answer first.
and the answer. Oh, we wanted to
Remember
watch the movie.
I remember.
That's right. Well, let's watch a movie. We're going to pause here. So this is the movie that I told you guys. Did anybody watch Freakonomics? I'm going to pause this because I don't want to get a copyright violation. Resume. Okay. I'm going to share my screen here. Okay. All right. So as we look at this, it says here that the prison increase caused a 30% reduction in crime. Or no, that's not exactly what it says. 30% of the crime decrease can be attributed to the increase in prison. So what we're saying is my R squared equals 0.30. Well, we know that's the correlation squared. What is the correlation? Who can do that in their calculator? It's the square root of that number, right? Okay, what is that? 0.548. Okay, now under the rules I gave you last week, would we call that strong, moderate, or weak correlation? We would call that moderate correlation, right? Now notice in here, so this is the prison increase. Prison increase. That's the biggest correlation we have. Our biggest is moderate, okay? Let's look at our crack decrease. Crack. The R squared is 0.15. What's the R in that case? 0.387. What would we call that normally? Still moderate, but almost weak, right? We'd call that moderate. And then we combine the other 3 because they're not very big. The R squared equals 0.10. What's the R on those other three combined? 0.31. So we barely stay with the moderate, right? If we took, and that's adding those together. Okay? So if we kept those separately, they would all be less than 0.3, right? Which we would normally call weak, right? Okay? And so you have to realize with simple models like we have, we can go with the 0.7 or greater than 0.7 is strong. But when you get into more sophisticated models like this, where we're putting a bunch of different things together, 0.548, that's the best one we got. And in this case, half of the crime drop is unknown. And so he goes on to explain he thinks it's a result of abortion. So I'm not going to go there, but it is a pretty interesting video. It's only 4.5 minutes, although I would have preferred to watch the previous part of that because that was interesting too. So I'll have to find that. So anyway, does that answer your question? Does that make sense?
0.548.
Okay.
I'm out of here.
All right. So, all right, we've got about 3 minutes left. Morgan, do you want me to go through and do one of these by hand? Okay. So I will record this. I don't think we can do it in 3 minutes. Oh, I still got this one up here. So here's what we could do. Since I've got this here, you want to do this by hand? So I'll put it this way. I'm going to stay here, and if you've got a few minutes, Morgan, we'll go over it, me and you, and anybody else that wants to stay, and if you want to leave, that's fine. But first of all, let me ask you guys, what is the equation for correlation? Do you guys remember that? Because I will give that to you. R equals sum xi x bar over s of x times y bar over s of y. Okay, so what do I need to get first? I need to find my means of x and y, which I have right there. And I also need my standard deviations. Those are already on my answer key, but normally you'd have to find that yourself. So remember, x bar equals your sample mean. Remember that mu equals your population mean. Y bar is also going to be a sample mean. It's your sample for your y data, and mu is still your population mean. Okay, so we're just distinguishing between the variables. Okay, so I've got my y bar and my x bar. Okay, now I can find my standard scores, right? Okay, can you help me do that? I need the standard scores for my x. Okay, so I'm going to take, what does x sub I represent? X sub I represents your data. What's my data for my X data here in this MRI count? It's going to be that big, huge number there, right? Minus, what's X bar? Sample mean, which in this case is 176,000. I'm going to F for that one because I always want to subtract off the mean, right? I'm going to close my parenthesis. And I'm going to divide by standard deviation, which is 65,000. Okay? I'm going to F for that one as well because I want the mean and the standard deviation not to change. So these two here are absolute references. This one here is a relative reference. Does that make sense? Okay? Now I need to do the same thing, the standard deviation for the y. The y is going to be my IQ scores in this case. So can you punch or tell me how to do this one? Use your parentheses. Equals 133 minus 134. F for that close parenthesis, divided by 3.12. F for that one also, right? Okay. Now, I need to find the product, right? So I'm going to take this number times that number. Now, I'm going to copy these down. Whoops. Okay. So I've multiplied these two together. What's my next step? Find the sum. And I'm going to click my auto sum button here. Okay. Then, oh, we forgot something on our formula, didn't we? Divide by n minus 1. What's my n in this case? It is 10, exactly. So I'm going to divide by 9. And the answer should be 0.359. Oops, I forgot to divide by 9. Hopefully I get 0.359. Booyah. Okay? You gonna ace my test? Okay. See y'all on Thursday. We'll be right here.
So my quiz 7 isn't put in. my
Oh, it's
grades.
not?
It's missing, so I just wanted to show you it. So you